So, in chapter transaction, today I am going to discuss schedules and serializability. Before I am going to discuss about the serializability, first we understand what is schedule and what is need of it. Schedule a sequence of instructions that specify the chronological order in which instructions of concurrent transactions are executed. That means if there is a transaction Ti having some instructions that must be executed during the transaction's processing, so that instructions of a particular transaction must be executed in a particular sequence. So a schedule for a set of transactions. Schedule means not only for a single transaction. If the system having only one transaction, then we are not concerned about the schedules. We concerned about the schedules when the system having more than one transactions. So a set of transactions must consists of all instructions of those transactions. So that means all the instructions of a particular transaction must appear properly so that it can reflect all the modification on the database successfully. And the schedule must preserve the order in which the instructions appear in the each individual transactions. So if there is more than one transactions, Ti, Tj and Tk, three transactions are there, if we consider, and Ti having some instruction, set of instructions, Ti, Tj also having some set of instructions, similarly Tk also. So all the instructions of a particular transactions Ti appear and must execute in that order. So that means a schedule having more than one transaction, each transaction having some instructions in a particular order, and the execution of individual transaction must be executed in a particular chronological order in which the transaction, in which the instructions appear chronologically. So a transaction that successfully completes its execution will have a commit instructions as the last statement. So we know commit statements save the modifications made on database. Whenever we perform some modification, some updation on database, that must be saved, that must be preserved. So to save the updation made on the database by a transaction must be saved, and that is done by the command commit operation. That means a transaction when executed successfully, and if all the modification updation reflects on the database properly, then there must, to save the updation or modification, we need a commit statement at the last of the transaction. By default, the transaction assumed to execute commit instruction as its last step. In general, when we in our lab, when we in SQL, when we do the SQL, when we do the query, then in general we never write commit operations. Say if we write insert into table names and values so and so, then we never write commit operations, because the here when we load the Oracle, then by default the commit operation is on. We set the commit operation on which means whenever we execute any command which is DML, which DDL, whatever it may be, and that deals with the database, must be saved automatically. That's why in general, usually we do not write commit operations. That's why here I'm writing by default transactions assume to execute commit instructions as its last step. A transaction that fails successful completes its execution will have a abort instructions as the last step. If transaction fails due to any reason, that means due to system failure, due to power cut, due to database crash, due to OS crash, whatever it may be, due to any reason, when a transaction fails, that means when transaction not executed successfully, then the transaction must be aborted, so that whatever modifications made on database must be rolled back, so that we can get back the prior or initial values prior to the start of execution of the transactions. So in a nutshell, schedule means system having at least two transactions, each transactions having some set of instructions in a chronological order, and the transactions of a set of transactions executed in a particular order. That is the schedule. Whenever the schedule finishes its all works, all instructions successfully, each individual transaction must save whatever it made on the database permanently. For that, we perform commit operation. So let us here, I am going to discuss with some example. Yes. There is schedule 1, and we are taking two transactions T1 and T2. Two transactions T1 and T2. That means it is a schedule, more than one transactions. And these are the set of instructions of the transaction T1, and these are the set of instructions of the transactions T2. The all instructions of the transaction T1 appears together. Similarly, all the instructions of the transactions T2 appear together. So here, let transaction T1 transfer rupees 50 from account holder A to account holder B. So that means we consider here two account holder of a bank, A and B, and account holder A transfer rupees 50 to the account holder B. Also, we assume the T2 transaction T2 transfer rupees 10% of the balance from A to B. Initial value of A is 1000 and initial value of B is rupees 2000. So here we consider two transactions T1 and T2. Also we consider two data item A and B, where the initial value of the data item is 1000 and the initial value of the data item B is 2000. Transaction T1 transfer rupees 50 from account holder A to B. Transaction T2 transfer 10% of its balance from account holder A to B. So if the transactions T1 and T2 execute in this chronological order, that means T1 followed by T2. So that is serial schedule. Serial schedule, schedule may be serial or maybe non-serial. In this case, this is the serial schedule. Serial schedule where all the instructions of a particular transactions appear together and executed first, then other transactions or the next transactions whose all the instructions appear together and executed. So this is serial schedule. T1 executed first, then T2. So T2 will start its execution after finishing of T1. So here T1 first read the data item A. So here T1 read the data item A means T1 reads the value of A, which is the initial value. Here we assume initial value of data item A is 1000. So read 1000, A equals to 1000. Then there is a computational step, A equals to A minus 50. That means transaction T1 transfer rupees 50 from account holder A to B. So since T1 transfer rupees 50 from account holder A to B, so there must be A must be debited. So A equals to A minus 50, write A. So what will be the value of A? 1000 minus 50, so 950. So when you write A, that means now the value of A is 950. Initial value of A is 1000, which is read by the transaction T1. After modification by T1, T1 write, modify, update the value of A, which is now 950. T1 now read the data item B, which is the initial value. Initial value of data item B is 2000. So read B means initial value of B, that is 2000. Now, since T1 transfer rupees 50 from account holder A to account holder B, so B will be credited with rupees 50. So B equals to B plus 50. And write B. Then T1 update the value of the data item B, which is 2050. That means T1 read first initial value of A, update the value of A, modify the value of A, that is 950. T1 read the initial value of B, which is 2000, modify the value of B, which is now 2050. Commit. That means all the modifications saved permanently. Commit means here what are the modifications done by T1? Write A, write B. Read A is not the modification. It only retrieve the value of the data item. But whenever a transaction performs write operation, that means transaction T1 modify that particular data item. Here T1 performs two write operations, write A, write B. So here two modifications done. That's why all updation made by T1, that means write A and write B, saved permanently. So now the value of A, data item A, account holder A is 950. So account holder A initial value rupees 1000. Now the account holder A rupees 950. Account holder B initial value is rupees 2000. Account holder B now the value is rupees 2050. After finishing this, T2 will start its execution since this is a serial schedule, T1 followed by T2. So here T2 read the data item A. So now what will be the value of A? A is 1000 initial value. But before T2 read the data item A, T1 already performed write operations. Before T2 read the data item A, T1 already modified the value of A, which is now 950. So read A equals to 950, rupees 950. Not 1000, because 1000 initial value that is updated by T1 and the updated value of A equals to rupees 950. That's why when T2 read the value of A, that is A equals to 950, then T2 transfer rupees 10% of the balance from account holder A to account holder B. So it takes some temporary variable. This is the computational steps. And after finishing the computational steps, T2 perform write operations on data item A. So A 950 10% means after debited from account holder A, the balance is write A equals to A rupees 850. So T2 read the value of is 950, which is modified by T1, and T2 modify the value of A, that is A equals to rupees 855. Now T2 read the value of B, data item B, the value of the account holder B, the balance of B, which is already modified by T1. T1 modify the data item B, the balance of B. The balance of B is now 2050. So when T2 read the data item B, that is 2050. After computational steps, T2 perform write operations on data item B, and that is B equals to 2145. So final value of data item A is 855. Final value of data item B is 2145. Now check before execution the sum of A plus B, total amount of account holder A and account holder B. The initial value of account holder A is 1000. Initial value of account holder B is 2000. So 1000 plus 2000 is 3000. After successfully completion of this schedule, that means T1 and T2, the sum of the balance of A plus B equals to also 3000. If you add the value of 855 and 2145, we'll get A plus B. That means this schedule, sum of A plus B is preserved. So we say that consistency is satisfied. Similarly, the same set of instructions of the transaction T1 and T2, if we consider, here we consider T1 followed by T2, if we consider T2 followed by T1, then T2 will execute first, then T1 starts its execution. In the previous case, T1 followed by T2, that means T1 execute first, then T2 will start its execution. In this case, we consider T2 followed by T1, assuming the same conditions. That means initial value of A is 1000, initial value of B is 2000, rupees 50 transfer from A to B by T1, 10% of the balance will transfer from A to B by T2. All the assumptions we considerations also true for schedule 2. So here T2 first read the data item A, which is the initial value of A. So initial value of A is 1000. After completion of these steps, write A, T2 performs operates write operations on the data item A. So that is 900. So now the balance of account holder A is rupees 900. T2 now read the data item B, which is initial value. So initial value of B is 2000 according to our consideration. After this step, T2 performs write operations on data item B. So B equals to, this is credited by this amount, so 2100. Then commit. So whatever modifications made by T2 reflected on the database must preserve. That's why we perform commit operations, saved permanently. Then T1 starts its execution. So after finishing T2, T1 starts its execution. And T1 read the data item A. This value is not the initial value of A because T2 already perform write operations on data item A. That means T2 already modify the value of A. So the current new value of data item is 900, which is not initial value. Initial value is 1000. So write A, that means T2 operates modifications on data item A. So modified value, updated value of A is 900, rupees 900. So when T1 read the balance of A, that is the modified value, that's why A equals to 900. And T1 transfer rupees 50 from account holder A to account holder B. So A equals to A minus B, the debited amount is 50. So now T1 performs write operations on data item A. So it is now A equals to 850. T1 read the data item A, which is already modified by T2, that is 900. So read A equals to 900. Now T1 modify the value of A. The updated value of A equals to 850. rupees 850. So the balance amount of account holder A is rupees 850. Now T1 read the data item B, which is already modified by T1. Sorry, T2. T1 read the data item B. T1 read the data item B, which is already updated by the transaction T2, right? B. So the updated balance of the account holder B is 2100. So when T1 read the data item B, that must be the balance updated value of the account holder B, that is rupees 2100. Then it credited by rupees 50. T1 performs write operations on data item B, and that is 2150. The final value of account holder B, final balance is 2150, and the final balance of the account holder A is rupees 850. And T1 performs commit operation. That means saved permanently all the changes made on the database by the transaction T1. Here also we check the before starting of execution of the schedule T1 and T2, having the transactions T1 and T2, the sum of the total amount of account holder A plus account holder B is 3000, because initial value of account holder equals to 1000 according to our assumption, and the initial value of the account holder B is 2000, so total amount is 3000. After finishing this schedule, after successful executions of the transaction T1 and T2, where T2 followed by T1, the sum of the amount is 3000. So if we add final value of A 850 and final value of B 2150, we will get 3000. So these two transactions, schedule 1 and schedule 2, these two schedules are serial schedule. That means here in this schedule, two transactions T1, T2, T1 followed by T2, that means T1 execute first, then T2. That means all the instructions of T1 appear together and executed chronologically according to the order. Then T2 will execute all the instructions of T2 appear together and executed according to the order in which they are executed. Similarly, schedule 2 also serial schedule, followed here T2 followed by T1. That means T2 execute first, then T1 will start its executions. That means T2 execute first. Since this is serial schedule, all the instructions of the transaction T2 appear together and executed according to the order. Then after finishing T2, T1 starts its execution, and all the instructions of T1 appear together and executed according to the order. So this schedule 1 and schedule 2 are serial schedule, where one transaction will start, one transaction executed first, then other transaction starts its execution. For the both schedule 1 and C2, the sum of the amount before execution and after execution is preserved. So schedule 2 also sum of A plus B is preserved. So both cases, in serial schedule 1 and serial schedule 2, both cases we proved that consistency maintained. Now if we consider the same schedule as having two transactions and T1 and T2, but here the execution of the schedule not serial. So schedule may be serial schedule. These two examples, schedule 1 serial schedule, schedule 2 serial schedule, and this is non-serial schedule. This is in the interleaved form. That means all the instructions of T1 is not appear together. See, the set of instructions here appear together, other set appear together. Okay, so let T1, T2 be the transaction defined previously. That means here in same schedule we consider set of transactions T1 and T2, same set of data items A, B, account holder A, account holder B consider. You also consider the initial value of account holder is 1000 and the initial value account holder of B is rupees 2000. We also consider rupees 50 transfer by the transaction T1 from account holder A to B, and 10% of the balance will transfer by the transaction T2 from account holder A to and B. So the assumptions for the transaction T1 and T2 and AB are the same. Now, if we execute in a non-serial serial interleave form, then T1 read A, write A, T2 read A, write A, then T1 again get chance to execute his instruction read B, write B. T2 again get his chance to execute instructions read B, write B. So here T1 first starts his execution, then leave the system for execution of the T2. T2 now starts his execution, then leave for the execution of T1. After finishing this, T1 leave for T2. So this is interleave form. In this case, T1 read the data item which is initial value. So A equals to rupees 1000. After modifications, T1 modify the data item A, write operations on the data item A. So the value of A is 950. T2 read the data item A. So what will be the value of A? See, before reading the data item A by the transaction T2, T1 already updated the value of A. Before reading the data item A by the transaction T2, the value of A already updated, modified by the transaction T1. So that means when T2 read the data item A, that is not initial value, that is the modified value. So when T2 performs read operations on data item A, the value must be the modified value, that is A equals to 950. Then T2 performs write operations on the data item A. So the value of A has been changed, and that is 855. Then again T1 performs to execute its instructions. T1 performs read operations on data item B and the value of B is initial value of the data item B, initial balance of the account holder B, that means 2000. Then T2 performs write operations on data item B after credited rupees 50, the value of B is 2050. So when T2 operates read operations on data item B, that means this is not initial value of the account holder B, because before T2 reading the data item B is the value of B already modified by the transaction T1, and that is a 2050. So the current balance of the account holder B is rupees 2050. So when T2 did the data item B, read the balance of the account holder B, that is the current value, rupees 2050. Then after computational steps, T2 performs write operation on data item B. So this is 2145. So if we here see the instructions of T1 are not together appear. Similarly, instructions of T2 are not together appear. So this is not serial schedule. This is equivalent to some serial schedule. We can convert it to some equivalent serial schedule. Okay. So this is non-serial schedule. So check the before execution, the initial value of A is 1000 and initial value of B is 2000. Total amount of the account holder of A and B is rupees 3000. After execution of T1 and T2, what is the value of A? See here, the final value of A, this is not the final value, because after this T2 also updated the value of A. So final value of A is 855. The final value of B is this is not 2050, because after modification this value T2 also modify the value of B, that is 2145. So final value of A is 855 and final value of B is 2145. So if we add A and B, 855 and 2155, we will get rupees 3000. So here also sum of A plus B is preserved. Before execution, the sum of A plus B is 3000. After execution, sum of A plus B is also 3000. So consistency preserved. It maintains the consistency. So this is non-serial schedule, but it preserves the consistency. And if we allow the schedule S having two transactions T1 and T2 in an arbitrary mode, then let us consider T1 read A equals to A minus 50. Before performing write operations on data item A, T2 read the data item A, read the B, T2 write operations on data item A, T2 also perform read operations on B, then T1 performs write operations. So in this case, what will be happening? Considering the same set of assumptions, T1 and T2 two transactions, A and B are two data items, initial value of A is 1000, initial value of B is 2000, and 50 rupees transfer from account holder A to B by T1, 10% of balance is transferred by from account holder A to B by the T2. So when T1 read the data item A, the balance of account holder A, that is the initial value 1000, then it computational step A equals to A minus 50. See, this value, this is not done on the database. This is in the buffer, local buffer, that means RAM. So this changes does not reflect it on the database. Before performing write operation, T2 already did the data item A. So what will be the value of A? A again the initial value 1000, because T1 read data item A, then in local buffer T1 performs A minus 50, that is 950, but not updated on the database. So on the database, the value of A still 1000. That's why T2 read the initial value of the data item A, which is 1000. Then it performs some computational steps, write A. So T2 performs write operations on data item A, that is 900. Then T2 performs read operations on data item B, which is the initial value. Now T1 performs write operations on data item A. See, before performing write operations on data item A by T1, T2 already performed write operations on data item A, that is 900. But what will be the value of A? This value is this, because in the local buffer for the transaction T1, in the local buffer A holds the value 950. Now when T1 performs write operations on data item A, this value will be changed. So now the current value of A equals to 950. See, the current value of A is 900 not. This is not the current value, because after write operations by T2, T1 again performs write operations on data item A, which is 950. Now T1 read the data item B, so this is 2000. Here T2 also read the data item B, 2000. Before changing or modify the value of B, T2 read data item B, T1 also read data item B. So the balance is same. So B equals to 2000. Then it performs write operations. Transaction T1 performs write operations, operates on write operations on the data item B, that is 2050, and save. So the value of A for the transaction is 950 and the value of B for the transaction is 2050 and save. But this value, when T2 perform write operations on data item A, that is 900, not saved permanently on the database, but this write operations saved permanently on the database since commit operations is performed. So again, this is local buffer, but when performs commit operations, it permanently saved on the database. Now T2 here read the data item B 2000. Then it performs these computation steps. Before performing this, T1 already updated the value of B, that is 2050. But before updation by T1, T2 already hold the initial value of 2000. So this B equals to B plus temporary value, that is this value, is on the 2000. So B equals to 2100. Write B 2100. So what will be the last value of B? This or this? No, this one. Because after write B performs write operations on T1 and commit, the overwritten the value of B by T2, that is 2100. After modify the value of A by the transaction T2, A equals to 900, T1 or overwrite the value of A, write A, and saved permanently. So the final value of is 950 and final value of B is 210. So here if we check before execution, according to our assumption, according to our consideration, A and B, A is 1000, B equals to 2000. So A plus B equals to 3000. After execution, the final value of A is 950. Final value of B is 210. If we add, we will get 3050. So does not match with the sum of A plus B before execution. Before execution, sum of the balance of account holder A and B is 3000 rupees 3000. But after execution, sum of the balance of account holder A and B is 3050, which is not consistent. So it does not preserve. So if the schedule is non-serial schedule, this is also non-serial schedule. This is also interleaved form. If the schedule is non-serial schedule and if it execute non-serial schedule execute in its own manner, in a arbitrary manner, arbitrary order, then the database may be inconsistent. That's why we need to control the concurrent execution of the schedules. Okay. Here this now we are in the point to define the seriality. Here in this serial 1, serial schedule T1 followed by T2, serial 2, this is also serial schedule T2 followed by T1, and we check both cases the consistency preserved. Here schedule 3, this is not serial schedule, this is non-serial schedule, but still it maintains the consistency of the database. This is also non-serial schedule but does not preserve or maintain the consistency of the database. So each transaction preserves database consistency. Otherwise, because we know that DBMS never support inconsistency. So whatever may be the schedule, serial schedule or non-serial schedule, transaction must preserve the database consistency. So serial execution of a set of transactions preserve database consistency. We have already proved for the schedule 1 and schedule 2 example. And a schedule is serializable if it is equivalent to serial schedule. That means this schedule does not preserve the consistency, but this schedule, schedule 3, this non-serial schedule, interleaved form schedule, preserve the consistency. That means the reason being this schedule is equivalent to some serial schedule. That's why it preserves. And this non-serial schedule does not equivalent to some serial schedule. That's why it does not preserve the consistency. So that's why now question is how we can prove that which non-serial schedule is equivalent to some serial schedule and which is not. So to different forms schedule equivalence gives. The equivalence one is conflict serializable, another is view serializable. So before going to discuss about the conflict serializable, we simplify the instructions of the transactions. Which instructions we must write to explain and which we may ignore, and which in which form. See, in this case, if we consider read a equals to a minus 50, write a equals to a minus 50 is computation steps. So for the sake of simplicity, we may ignore this statement, but read and write operation must be there. Similarly, b equals to b plus 50, we may ignore. Tem, a equals to a minus 10, b equals to b plus, that means computational steps we ignore. We only consider the read write operations. So here ignoring operations other than read and write operations. So because the other than read write operations or other operations does not deal with database, here a equals to a minus p, this is done in the local buffer, not in database, in the RAM, volatile memory. So that means the does not deal with the database, but read and write operations deal with the database, access the database. But here a equals to a minus 50, 10 equals to a into 0.1, a equals to a minus 10, b equals to b plus 50, b equals to b plus 10. These does not deal with the database, does not access the database. It is all these operations are executed in the RAM, in the local buffer. So that's why we only consider read operations or write operations. We also assume that transactions may perform arbitrary computations on data in local buffers in between reads and writes. That's why I'm telling you that this is done in the local buffer. There are so many computation steps may be there between read write operations, but all are in the local buffer. So our simplified version, so we can write our simplified version, read a, write a, read a, write a. Okay, so that means we only consider read operation, write operation. Between read and write and all the other operations which does not deal, all the other operations which do not deal with the database, which do not access the database, which is only executed in the local buffer, we ignore. So we simplify the view of transaction, that means simplify the set of instructions of the transaction. Now, I told you this, how we can conflict serializability, and be sorry, today I am going to discuss only conflict serializability. So conflict serializability, before whether the instructions are conflicting or not, based on that we can conclude that which schedule is conflict serializable and which schedule is not conflict serializable. So first check whether instructions are conflicting or not. So let us consider two instructions II and IJ. Instructions I is a read, write. Instructions means here which instructions we consider? Read operations and write operations. So II and IJ, these two are the instructions. So II may be read operations or maybe write operations. Similarly, IJ may be read operations or maybe write operations. So instructions II and IJ of the transaction Ti and Tj respectively. That means we consider two transactions Ti and Tj, and Ti having the instructions II, Tj having the instructions ij. Consider two transactions Ti and Tj, Ti having the instruction II, Tj having the instruction ij. So II and ij, these two transactions of the transactions T and T respectively, conflict. That means II and ij conflict if and only if there exists some item Q accessed by both I and ij. There exists some item Q means there exists the instruction II and ij access the data item Q. Here we consider data item Q. That means account holder A, account holder B, any value of the data item. So if and only if there exists some item Q accessed by II and IJ, and at least one of these instructions write queue. So this II and IJ, if any one of these two instructions, I and IJ, any one of these two instructions is write operations, then and both I and IJ access the data item queue, then conflict arises. So when conflict arises, if we consider two transactions Ti and Tj, and respectively, we consider two instructions I and Ij respectively, then the instructions may conflict if at least one of these two instructions may be write operations, and both instructions must access the same data item. So let us explain. Say we know that II is the instructions of the transaction Ti, and Ij is the instruction of transaction Tj. Say II equals to read on data item Q, and Ij also read on the data item Q. So here Ti performs instructions II, that is read operations on the data item Q, and transaction Tj performs Ij operations, that is we assume read operations on data item Q. So here both the operations II and Ij are read operations on the same data item Q, then II and Ij do not conflict. Reason being, both the transaction Ti and Tj performs read operations on data item Q, which only read the value. If you consider initial value, the initial value just read the value, does not change the value. Transaction Ti here read operation does not change the value of the data item Q. Here also transaction does not modify the value of the data item Q. So only retrieve. So that's why if both instructions II and Ij are read operations on the same data item Q, then II and Ij do not conflict. But if II equals to read operations on data item Q and Ij write operations on data item Q, then conflict. So why conflict? Because that if we consider Ti first did data item Q and then Tj performs write operations. So when Tj performs write operations, there must be. So that means here Ti only performs read operations and T2 performs write operations. So that means write operations performed after read operations performed by the transaction Ti. So this is the initial value, and the initial value of the data item is changed by the another transaction Tj, because Ij is the instructions of the transaction Tj, not Ti. Here this instruction is read operations performed by which transaction? Ti, on which data item Q. And here the instructions Ij equals to write operations performed by which transaction? Tj, not Ti, and same data item Q. So here the value is changed by Tj. Here value is retrieved by Ti. So they conflict. Similarly, if the change II equals to write operations on data item Q performed by Ti, Ij equals to read operations on data item Q performed by Tj, then also see Ti modified the value of Q, but Tj read which value? This value is modified value, not the initial value, which is modified by Ti. So they conflict. And if II and Ij both write operations, then conflict. So see, in this case, the condition 2, 3, 4, 3 cases, case 2, case 3, case 4, here at least one operation is write operations. So if between two instructions I and Ij of the transaction Ti and Tj respectively, at least one operation is write operation, then conflict arises. So intuitively a conflict between I and I forces a temporal order between them, logical order. That means if I and I are consecutive in a schedule and they do not conflict, the results would remain the same. Let us check. So say T1 and T2, this is a schedule. Say our schedule 3, see schedule 3, T1 read A, write A, T2 read A, write A, T1 read B, write B, T2 read B, write B. We consider this schedule here to explain our concept of serialibility. T1, T2, read A, write A, read A, write A. These are the computational steps. Read B, write B. This is computational step. T2, read B, write B, computational. Now, we only consider read-write operations, ignoring the computational steps. So, read A and write A, then read A, write A, read B, write B, read B, write B. And in between the other steps we ignore because the other step does not access the database, does not reflect on the database that are performed on the local buffer in the RAM. So say here T1 performs write operations on data item A before T2 operates read operations on data item A. Okay. So can you see here if at least one operations read write, then conflict, so you cannot swap here, so you cannot swap. Now see, write A operations performed by T2, T1 perform read operation data item B. So T2 performs write operations on data item A, then T1 performs read operation data item B. Does it conflict? No. Reason being, T2 performs write operations on data item A and T1 performs read operation data item B, so different data item. If on different data item, the conflict does not arise. Conflict arises when same data item. Here, T1 performs write operations on data item A, then T2 performs read operation data item A. They are conflict because on the same data item A. But here T2 performs write operations on data item A and T1 performs read operations on data item B. They do not, these two instructions do not conflict. Reason being, this performance on the different data item A and B. So we can swap. We down write A, we up write read B. So এই ক্লাসে আছে sorry. So here T2 performs write operation on data item A, T1 performs read operation on data item B on different data items, so we can swap, they do not conflict, so we can write the write operations here and it be up and down. Similarly, see read operations on data item A, read operations B. First of all, both are read operations, does not conflict, and on different data item never conflict. So we write read operations on data item B here and read write down, one step down. T1 performs write operation on data item B and T2 performs write operations on data item A. Both are write operations, so obviously conflict, but not. Reason being, T1 performs write operations on data item B, whereas T2 performs write operations on data item A. So two different data items. So conflict arises on the same data item. At least one write operation must be there and on the same data item. So here both are write operations, but on the different data items. So never conflict. So we can swap. So we can swap the write operations on data item A one step down and one step up. We can swap it. So in this way, read A and write B also do not conflict on the defined data item A and B, and after swapping we will get the final sequence of the instructions for the schedule S or for the transaction T2. Read A, write A, read B, write B. T2, read A, write A, read B, write A. That means all the instructions of T2 appear together here, and all the instructions of the transaction T1 appear together. So see here, if all the instructions of a transaction appear together and executed fast, then other instructions are executed by the T2, that is serial schedule. Just we discussed at the beginning. So this is the serial schedule, or T1 followed by T2, where all the instructions of T1 appear together and executed fast, then all the instructions of T2 appear together and executed after finishing T1. Same, so this is equivalent to this. So this schedule is equivalent to that schedule 1, serial schedule 1, T1 followed by T2. So T1, all the instructions of the transaction T1 appear together, all the instructions of the transaction T2 appear together, and execution of T1 fast, then T2 starts its execution. This is equivalent to serial schedule. So if a schedule S can be transformed into a schedule S test by a series of swaps of non-conflict instructions, we say that S is a conflict equivalent, and we say that schedule S is conflict serializable. So here this is non-serial schedule. This schedule is non-serial schedule. After swapping all the non-conflict instructions, we are getting this. This is non-serial schedule. This is interleaf form schedule. And after, according to the rule of the conflict instructions, which are non-conflict instructions, we can swap. Conflict instruction cannot swap. So based on this concept, on this rule, we, after swapping this non-serial schedule interleaf form, transform to some serial schedule. This is serial schedule. So that means if a schedule S can be transformed into a schedule S test by a series of swaps. So here this is a schedule S. If a schedule S can be transformed, here schedule S is transformed to a schedule S test by a series of swapping, of non-conflicting instructions. We say that S and S test are conflict equivalent. So these two schedule, if you say S, if you say the S test, these two schedule S and S test are conflict equivalent. So now we say that schedule S is serializable schedule, because schedule S is transformed to some equivalent serial schedule. Clear? So this is all about the conflict serial schedule. Okay. Next class I am going to discuss the another form of serializability, that is view serializability. Okay.